Hello guys. So today is in addition to my previous tutorial for the stylized grass, and we're gonna make procedural stylized flower. By this I mean that the shape and overall variations of the flower will be calculated only with the math. So let's get started. Before we start, here is my model that I'm using for applying procedural texture. As you can see, it's nothing fancy in the UV, so we have just basic UV layout from top left to the bottom right corner. I only have subdivision by 4, and they are made in the way so the middle point here is a little bit distorted, as you can see from this angle. So it's basically for better overall shape, and if I have subdivision by 4, once I've added the wind, the bending will be a little bit better. There are many ways on how you can populate your foliage. In this example, I'm gonna use the grass node for my landscape material. So here you may see that I have this one. I provide 1, which means that the whole area where my shader is on my landscape, there will be grass. And here on the left, you may see that I have the landscape grass actor. And here you may see how it looks. So basically index 3 and index 4 is for the flower. I'm using the flower plane in both examples, but with different settings. So those planes are the one that I showed you previously in my Blender. So we have different density, we have different scaling, and different distribution. That's actually it. So it's up to you. You can actually go and paint your flower with the foliage tool. Just do how it's better to you. And also you may see that I have the material override in both of my examples. So I have one master material, but I have 2 different instances with some particular changes, so I can control the flower better. So this is one variation, and this is the second one. And the overall shader looks like this. I'm going to explain everything to you step by step. This one is for the interaction and the world position offset, but the main magic happens here. So this one part is for generating the shape, the color, and so on. So here we have the petal shape generator. We start with the simple texture UV node. By default, it looks like this. And the pivot point for all distortions is in the top left corner right here. The petal distribution starts from the center, so we need to shift this pivot to be at 0.5 here in the middle of the plane. For this I use constant bias scale with the values -0.5 and 2 on scale. Now that's how it looks. If we mask each channel, we can have the color distribution or the direction at which we can pan over the texture coordinate space. So let's say if I go like this, you may see I have from left to right or vice versa, and for the green channel the same, from top to bottom or vice versa. So if we have those directions, we can understand how the distribution comes. But the petal should be created with distribution from the center on the radial gradient. So like think of the clock where we have the sectors like 1, 2, 3, 4, and 5. So distribution is the same as the clock. To make this one happen, we actually need to use arctangent 2 to create the radial distribution. Like this. You may see that we have sort of distortion or the parallax effect at the bottom here. If we divide this one by the pi, because we have the radial gradient right now, we can create sectors. You may see that I have petal count here. Also here in calculations I have the roundness and width. Those are the named root nodes, and I use them to have my graph tidier and cleaner. Think of them as the simple scalar attributes. Also, you can see that nearly everywhere I have the per instance random and the lerp between some values. Those values and this node create the randomness for each flower that I have on my scene. So let's say if I have scalar like this, and maybe what I have, yep, those values. Take a look how this one works. Let's also say that I have this one as the petal. So we have 1 petal, 2, 3, 4, 5. Next, the width, right? So it might be like this or like this. And the roundness of the shape, like this or like this. So this simple logic with lerping between values helps me to have the random form for each of my flower. So next is to have the sign node to create sorts of repeating pattern. So if you take a look at this gradient, if you use sign, right, with the specific period of 1 here, we have those bands. If you have period 2, we have only 2 bands. If period is 0.5, we have 8 bands, and so. But those black ones are the masks that should be removed, and the white only exist. Also, you may see that distribution starts from the 0 to 1, but we need to make them shift 0.25, so the distribution will be the same on the whole UV space. For this, I can multiply sign by itself, create this type of pattern, because without it, that's how it looks. So the same one sector, but with 2 different values. Cosine here stands for not allowing the whole thing come over the UV space. So that's actually how it looks. As you can see, the values are a little bit high because they are outside of the range of 0.1, so we need to straighten them. And as you can see, we have the edges of each petal sharp, but they don't look like the round one. For this, we need to create the radial gradient and use it as the mask to bring roundness to the whole petal shape. For this, I use the following: distance with this texture coordinate, which creates the radial gradient or the radial mask. And we need to inverse it, so we have something like this. Power here stands for the roundness and multiply for the width. And if we combine everything together, round and sign, to have the precise sharp mask, we actually get the petal shape. But as you can see, the petal here starts from the center, and some flowers can have the face like the daisies, right? So we need to subtract the face so the petals will be independent. So they look like this, and I need to change the size of the face, for instance 0.5. So here I subtract the flower face mask and saturate everything so the mask is inside the 0 and 1 range. For the flower face here, you can see I have the same calculation that I have here, right? Minus 0.5 and 2 on the bias scale, distance 0. Next, I divide this mask to have the size of the face, right? I inverse the mask, round it, so the values are sharp, and saturate, so the flower face comes, like this, right? Because without roundness, we will have something like this. They are not sharp, and once I apply those masks together, the face and the petals, they will be different in the intensity, but intensity should be the same for all of them, because we are doing the stylized look, and we don't need to have the subtone in colors. For the face controls, I also have the same logic. So per instance, random, minimum and maximum, and I start with the 0 and end up with something that I like. So if I have 0, it means some flowers won't have the faces. One more thing for the petal counter control. Without this operation, if you start changing the number of your petals, you may lead to the results where the petals are intersection one inside other. So to deal with it, we need to round the value that we have here, divide it by 4, and then divide 1 by the result of this one. So that means that we kind of withdraw sub-values and round everything up to the value that we are entering. So 1 will be 1, 1.2 will be 1, 1.5 will be 2, and so on. Now let's talk about the petal noise. Noise here is to make the variant for your flower, so it won't be on one solid color, but the variants of 2 colors. It might be 3 and 4, it's up to you how to get this. So here you can see I have the noise styling, it's the scalar, multiplied by texture UV coordinates, append 0 because the noise node works with the vector 3, and this operation will change the size of the tiling of this noise. Here you may change the values that you like most to have different look of the noise. And I use frag, and this one actually returns the following noise pattern. So without frag, I'm not gonna have those sharp edge white areas. I'll have the subtones, and this one doesn't simply work with the stylized look. It ruins the whole art style. So once I have this one, I can use the petal noise here in the colorized masking. So to have this color variation work, let's say we have the noise styling to be 0, it's the solid color, but if it's 1, I actually don't do it like here, I need to have this one also here so you can see the results. If it's 1, if it's 2, if it's 4, if it's 32, and so on. So by default, if you use 0 here, the noise generator, you'll actually have this kind of artifact. It's not the artifact, but this one returns the black color. And the black color multiplied by our mask will return the black flower, and we don't need to have this one. So to make this one work, we actually need to have the if node here to check what to provide as the mask for colorized stuff. So that's how it works. If the noise styling is higher than 0, we use the petal noise, this one, and multiply it by petal shape, the shape that we have up here. So basically it will return the following. Oh, wait, we also need to have this one. Let's say we have 2 here. So yeah. Or maybe like 4 here and so. And if we have it 0, we only return the petal shape. So it will be the simple white color, the solid color. Next, we use 1 minus, round the value, multiply it by the 1 color to have one variant. And without 1 minus, we have the opposite mask, but with the other color. Next, we add everything, so we have the color variation, like this. And because you see, we are out of the mask range, we need to clamp the overall stuff with the petal shape mask. So we clamp, use the petal shape, the result of this calculation. So we can have something like this. Next, we need to add to this one the flower face. So flower face here is the mask for the face, obviously, right? And once it's added, let's say we have the face 0.5, you may see that we have the face, we have the petal, the colors not overlap, intensity of each mask is the same, and we have kind of nice result. Colors are made the following, and you can make it the way you like. So I have, for instance, random, the hue shift, which will make the different color from the textures I have here, and I use petal color A here, petal color B here, and just combine them here, right? And to make this one work as the mask, I need to actually compute the whole mask. So the petal shape that we have up here, right? This one, plus the flower shape that we have here, will end up with the global shape of our flower. And we use this one as the shape for our opacity up here. The last part here is about world position offset and the flower interaction system. To make flower interaction work, you need to have the mesh distance field checked for your project. So, project settings, rendering tab, and it's up here in the software ray tracing. Generate mesh distance field checked. So if you have distance to nearest surface divided by the scalar attribute, saturate and inverse the mask, it will return the mask from white to black, where the black area isn't calculated, but the white has the power to change the mesh distortion, right? Everything is controlled up here at the vector 4, where the simple scalar is for the interaction area. I also have the distance field gradient normalized to have the direction at which I'm gonna distort my mesh, and multiply by power. Power here is represented by the vector 3, where I have the same distribution on the sides, but the higher one on the bottom. So my flower is moved to the side a little bit, but once I step on it, it's moved to the bottom. to the ground. This one comes with the wind control here, and everything goes to the world position offset. So wind control is the simple grass wind, and this one is needed to distribute the flowers on a different height on my landscape. So some of them are on the 35 units from the ground, some of them on the 60. And that's how the wind is done, right? Also, no grass mask is for the object that's stand on the ground, and we don't need to flower and grass pop through it. So if the distance is 70 units and higher, there will be no grass at all. So this no grass is multiplied for the overall shape here, as I said previously. So that's actually how the flower generator is done, how it works. Also, you may see my changes to the material instance variations. So let's say for the solid color flower, I have the phase, right? From 0.35 up to 0.5. Noise here is 0, 0. So that's why I don't have the pattern. But if say I have 4, you may see that I have this one. And the petal, I guess, controls, we have the minimum and maximum size of the, not size, but count of the petals. So the solid one on the scene start from the 4. But if I start with, I guess, 3, you may see how it's changed. So yeah. And for the kind of daisies, I don't have the phase up here. So this one is 0. Number of petals are higher. Also, the same goes for the roundness and the width. So yeah, it's different from this one, from the fluffy one. So you just need to play around with those, and you'll have something interesting. We can also change the distribution density. So we have the flower field, let's say 35 here, and maybe 60 up here. So with this, you may see how many flowers we have. So guys, I hope you like this tutorial, and for my patrons, I'm gonna re-upload the grass tutorial sample with the flowers, so it will be updated. And as always, please subscribe to my channel, leave your feedback, press like button, shout outs for me if you can on the forums and so on. And I do have the Patreon page where you can download the sample project for some or for all of my tutorials, depends on the tier. The link is under this video, and thank you guys for supporting me, especially financially in these hard times. And with that, see you soon, guys.